Diecast, injection molded, 3D printed. How each of these cars look and function can be explained by the way they're manufactured, as well as what they're used for. For context, my channel is literally about 3D printing cars, specifically designed with a flat side so it can print without supports, allowing for interlocking parts without the need for assembly. But before I rate how well this contraption works, I want to show you how other wheel mechanisms work. In something like the Hot Wheels car, if I separate the body from the chassis like this, underneath, you can see that this rod bridges the wheels together. It looks deceptively fragile, but it does the job just fine. Now, on first glance, this rod makes it look like the wheels spin together, but you'll notice that I can spin the wheels in opposite directions from one another. I was initially under the impression that spinning one wheel would influence the other, but the rod just seems to be there mostly for alignment and ease of manufacturing, which is an important part of the design consideration. Some of you may have spotted that this car here is a transformer, and with all of its moving parts, it forgoes the luxury of having a stable axle that runs through the whole vehicle. Similar to the Hot Wheels, you can actually see the metal pin that holds the wheel in place, though it sits much deeper inside the wheel, which makes them wobble like this. But I don't think it impedes any function. In fact, I think it moves incredibly well, which leads us to the part that you clicked for. How does a 3D printed car work? Well, like I said, the sides of this car are flat so that you can print this thing in one go. Because if you printed the car from the ground up, you'd run into the issue of overhangs and flat tires. So as you can imagine, this 3D printed car has the wheels bound to the axle, and both sides spin with one another. So no independently moving wheels. Now, unlike the Hot Wheels and the Transformers, there's a little bit of leeway for lateral movement of the wheels. This is more of an artifact than a feature, but as far as I know, it doesn't harm the function. I've tested a few variations of this mechanism, and the one that spins the best is the design that minimizes surface contact between the axle and the chassis, which is why I have these semi-circular cutaways on the underside of the car. The next thing I wanted to compare is the weight. And we're going to exclude the Transformer from here on out, because it doesn't really strive for the same function as the other two. So my average Hot Wheel comes in at around 35 grams, whereas my average print might sit somewhere around 20 grams. But interestingly enough, the weight of the printed car can be wildly varied depending on the infill percentage you decide to use. So something like 15% infill might weigh around 17 grams, whereas something like 50% infill could weigh in at 27 grams. It should also be stated that adding external weights to either car is possible, which will be helpful for our next heuristic, that being speed. When put side by side, my Hot Wheels Corvette and my Corvette-inspired 3D print both perform like this. And then this is me comparing the 15% to the 50% infill. But speed isn't everything, because many people get into this hobby for the aesthetic craft, choosing to add body kits, add their own decals. I've even experimented with this myself with this spray-painted car. I'm looking forward to a future where machines like the new Eufy make are much more affordable and allow diecast and 3D printers alike to add their own paint jobs in the comfort of their own home. But without all of the machining equipment, it's a little hard for a DIY car like my 3D prints to catch up to the industrial processes that take place with Hot Wheels. But on the topic of customization, there's an undeniable level of accessibility to modification when you're working with digital files. Just look at the truck modding video I did last week, where I got viewers to submit their own remixes of a truck I released into the public domain. But the tools and supplies for getting started with a diecast mod are a little more intense. Not to mention how quickly you can iterate on large design changes with a 3D printer. Also, try doubling the size of your Hot Wheels next time you're at it. One super cool feature of 3D printing is that you can create a jumbo-sized truck, or you can print off these miniature trinkets that could work well as a trick or treat, which if you compare to the Hot Wheels would actually be a lot cheaper per car. And speaking of cost, if you already own a 3D printer, that's a large part of the investment out of the way. So from that point onwards, you could just compare your car purchases to your material cost for filament. And in some respects, you would be spending less money per car if you were 3D printing, especially when you factor in the cost of gas or delivery. But to be completely sincere, I don't think this is a fair comparison. It's kind of like comparing a high-end gaming computer to the latest PlayStation. Sure, the PC does a lot more, but the PlayStation is also really convenient. So putting the two side by side shouldn't just take performance or cost into account. But there are some obvious caveats. For instance, Hot Wheels has access to thousands of licensed vehicles, whereas I don't. Not only do I not have the resources to make clones of existing brands, but I also don't have the permission to distribute them. Now this does inspire some innovation on my end, allowing me to release a truck design into the public domain, for example. And it gives me the freedom to create what I want without having to adhere to someone else's design. And now, recyclability. This one can be a contentious subject. because it's not always clear that when we do our part, that the recycling services do theirs. But in theory, having a toy car made of one single material, like PLA in this example, would make it far easier to break down into raw material once again and manufacture something new. I don't think Hot Wheels are too far behind, however. They're made of just a couple parts, and if you scrub off the paint and remove the coating, I think you could largely break these down into their bare components again. And that's one of the upsides of having limitations. But with that said, limitations are one of the main hurdles we run into regarding 3D printing. Which leads us to the final analysis, that being overall appeal. So for clarity, I don't think 3D printed cars will catch up to diecast in market capture. The manufacturing process is slower, more niche, and somewhat limited in scope. But that doesn't stop 3D printing from having become a really captivating hobby for so many people. And 3D printed cars are just another extension of what one person, myself, can do to level the playing field of manufacturing your own designs. I think 3D printing is also a great teaching tool for young folks, or those getting into crafts or engineering. It massively decreases the time from concept to prototype, and some of the artifacts like the flat sides sort of create their own charm. Anyways, it's been a crazy week, guys. We've gained over 1,000 subs in the last 30 days, and I can't wait to keep growing the channel. So like the video, watch this next one, and tell me if there's anything you think I missed.